Yeah, my name's Michael Maletich, also known as Titch. My preferred pronouns are he, him, and his. And as you can probably tell from a lot of the earlier talks, Kotlin is one of the primary languages we use at ShopRunner. We decided to start using it about 2 years ago for our microservices, and it's worked out well ever since. But this talk isn't necessarily about microservices, this is about data. And Kotlin works pretty well for data. I mean, you've got Python there, and Python's always going to have the most libraries in data science, but Kotlin has the access to all the mature libraries of the JVM, and that is something to be said for. So what I'm going to talk to you about is like, what are the best practices that we found at ShopRunner for validating your data? And then we're going to go into an open source Kotlin library that we created that makes it easy for you to implement those best practices quickly and easily. And along the way, we're going to kind of talk through why Kotlin is such a great language for doing data management. So let's start out with a story. One day you find yourself in charge of an application. This application takes a CSV file and puts it into the database. And it works fine most of the time, but about once a month or once a week, you find yourself having to spend all day kind of fixing the application because the data that's coming in that CSV is coming in some unexpected way. Or even worse, sometimes you find yourself having to fix corrupted data. Raise your hand if this sounds familiar. Okay, good. We're on to something. We're going to call this legacy data. Michael Feathers, who wrote the book on legacy code, called legacy code code without tests. Well, we're going to refer to legacy data as just data without validation. But dealing with legacy code, or legacy data, is going to be harder than dealing with legacy code because more often than not, with legacy code, you can change the code. With legacy data, you're often just provided it. You are not the data provider, and that makes it pretty hard. Developers often don't think about validation until it's really too late. So let's talk through how we might deal with validating data. So one thing you might do is you get that data and it fails because you were expecting it in ISO datetime format, and they decided to send it to you in AM/PM format. So you, being a developer, write some code to figure out, like, looking at the regular expression, is this AM/PM or is this ISO? If so, I'm going to convert it from one format to the other, and you're done. You pat yourself on the back for being able to quickly ingest data, and you move on until like the next issue that comes up. Well, over time, this leads to a problem. What you find is you have your core program, your core business logic, and then you end up having to write all this adaptation code and maintain all this adaptation code as your program slowly deals with more and more problems of things coming in. And the reason that it's having to keep adding this adaptation code is because you're not getting feedback to the data provider about when they're sending you bad data. So you still want to be able to adapt to what you cannot change, but you also want to be able to quickly see when something's going to break and provide that information and those errors back to the data provider. The second thing that you might change is like, okay, so what you do in your code is you realize what is going to break and you start to throw exceptions when things fail. And this is great because you can quickly provide information back to them, but you make a mistake. You're throwing exceptions, and exceptions stop the world. They do not capture all the errors for the system. So if it takes time for that data provider to kind of fix those errors and get the feedback back to you, and then you to validate it again, then this back and forth is going to be rather slow. So the first time you tell them the first error, and then they fix that, and you run the program, and it validates the second error. You tell them, eventually they're going to curse you out, and you're going to be going back to adapting the program again. So you want to be able to capture all of the errors and do a full validation for that data. The third thing that you might see is you've got the exception handling, or you've got a full validation, you are adapting to what you can't change, but what you've done is you've added all your validation pretty deep into your program. So the error messages that you are providing back, and the error messages that you're providing back are relevant to the data structures inside your code versus relating back to the original data source. So then you're once again spending all your time converting the errors that your program are giving back to the data source provider. So just to kind of follow through on like what is it that we want when we're doing with a good data validation program. We want full data validation. We want to adapt to what we can't change. We want messages relevant to the source, and we want this written in Kotlin. Well, why do we want it written in Kotlin? Well, it is Kotlin everywhere. That's part of it. But there's a number of different validation tools out there, right? There's JSON, there's XSDs, there's Avro. The world goes on and these. And these are great for describing the data. And they will allow you to do some basic, they can do a fair amount of validation. So you can put in like, how long is your string? Does it match this regular expression? But for more complex business logic, like if this is an order, the value should be positive, and if it's a return, the value should be negative. Those are harder things to express in these languages like XML or JSON. So this is where a language like Kotlin really allows you to add more complex validation. But Kotlin's such a great language in being pragmatic that you can write very distinct and succinct code that can be just as good for the common cases like the string lengths and the string validation. So ShopRunner took all these ideas and we created an open source library called Baleen. Now it's called Baleen because baleen are the hairs in a whale's mouth, and they separate out the krill or the food from all the water and everything else. Similarly, Baleen, the library, helps separate the good data from the bad data. So the way that Baleen actually works is it takes in files like XML, CSV, JSON through various streams, and it applies a data description to that, which is similar to a schema. And from there, it produces out a stream of various errors and warnings that can then be provided and worked off of. You can also add custom tags to that data as it's coming in, so those errors can be more relevant to the data producer. So things like files, what the product ID is, etc. The way we talked about the data. So the data descriptions that we use in Baleen are just a set of constraints on that data, and you can have as many or as few as you want. And the constraints can be either expressed as the structure of the data, or they can be expressed as a list of tests. So we're going to jump into some actual code, some actual Kotlin code. And the way we're going to do this is I created a web application because validation code unto itself isn't very graphical. So we have a web application that kind of shows the validation code and what it's doing. And then we're going to dig a little bit into how Baleen is actually working and running off of that code. So let's see. Switch over to that. So what we have here is, this is the web application. That didn't work. So this is the web application when we get to it. Okay. No. Okay. This is the web application. We're not going to talk too much about how this web application is created, but what it's doing is it's basically we can point to a CSV, and it's separating out the valid products from the invalid products. And what these products are is, if I go over, it's reading in a CSV file. The CSV file is a dump of various products from Flipkart, which is an online retailer. And you can see in here there's things like the product URL, various images, the price, the description, etc. So it is simply running Baleen over it and displaying the products as either valid or invalid and the list of error messages associated with it. And right now, we haven't added any validation, so everything is under the valid category. So let's go over to our actual Kotlin code. And let's go ahead and do some validation. So you can see here, this is what the web app is calling. It calls get data from CSV file. We passed in the file name, and then it's validating with the product description. The product description is our data description, and right now it's blank and isn't actually doing any validation for the most part. So the way that we add validation is by describing it with the structure of the data. So we can say something like the retail price has a type of string, and we'll import that. And right now this will once again be valid because it's a CSV, and CSVs are basically sets of strings. So let's actually make it a little bit more constrained. And what we're going to do is say it's a string coercible to a float. Coercible meaning like parsable. And then we can give some constraints on the float constraint itself. Now if we build that and run it, and we go back to our web app. Okay, right away it finds a backpack in there that has no price. And so this is something that came out as the error string. And you can see here that Baleen has provided various information about that we've then parsed into a message. So it captures what was the attribute that it failed on, what the error message is, which was what the value was that failed, and some various data, and we're going to just display like the line number. We can further do validation and keep adding additional constraints. So we could say we want things like the minimum price to be 0. Build that. And we get a bag that is negative $199. So if you purchase that one, you will get $2,000 inside the backpack. So various things like that. So that is one way you can do it. So you're expressing the type of the data. But sometimes expressing things simply as types like this is not quite sufficient. So say, for instance, if we look back at the purses data, there is a column in here called overall rating. And you can see overall rating is mainly no rating available, or there's a couple different floats in there. So it's a string or it's a float. So what we're going to do is we're going to express this as a test. So it is overall rating, and its type is a string, and we're going to add a test to it. And the test is passed in a data trace. And the data trace is kind of like a stack through your data. So right now, when it's passed into there, it will know the file, the column, the row for that particular data, and it can be appended on additional tagging and attributes. And then we have the data itself. So we'll pull out of that data the overall price. Value equals data. And data is all Baleen treats data as just simply a hash map. And then what is expected out of the test is a sequence of validation results. And so an empty sequence simply means that it was successful, but it could then have more than one or more errors that are associated with it. So we'll say if value equals, we'll do the good case, so no rating available, or it could be data. The value is of type any, so it's a good thing we can do the cast to string, and because we've done the cast to string, we can say value to float or null, and we want to make sure that's not null. And if that's successful, then we return a sequence, an empty sequence, and if it's not, then we return a sequence of validation error, and that takes the data trace, which we're going to append on there where we're at. So this is attribute overall rating, and a message is not no available or a float. And the actual value itself. And I just missed a spot. Sequence increments validation result. Oh, I put that in the wrong spot. Okay. Save that, build it. Okay, and it pulls out another bag. So in this particular case, we've got a bag where it is actually, instead of the rating being no rating available or a float, it's saying TBD. So another case where the line would actually fail. Okay. So we can continue to add the various the code to validate and slowly over time make our data even more resilient and valid. Now, one thing that we're getting with this is we're actually getting a lot of metadata with each error. And what we could do is we can actually serialize that metadata, because more often than not, you're going to have these errors that maybe you can't actually correct. Either they've kind of been grandfathered in and you want to say you want to catch new cases of those errors, but you want to still be able to say that the errors that are there, we're just not going to correct them yet. The data provider is not going to do that. So what we're going to do is we'll take those, through this web app, we'll basically take the metadata from that and we'll serialize it to like a YAML file. So this just took the metadata from those errors, like the name of the test and the attributes. You could have additional metadata on there, like the product description, etc. And we'll just remove the stuff that would change, like the line number and the file. And then you can imagine what you would do is then say ignore failures from file, and those would be ignored in the future. But I'll leave that to the reader. So we've established things as tests. We've gotten a sequence, and because these are sequences and sequences are evaluated lazily, we can deal with very large sets of data being validated, because we only are going to be running the code of actually doing the test as things actually are processed. We talked about data tracing and tagging, which are important for actually capturing the metadata. And then sometimes one thing that you might actually find is that you've got a data provider who doesn't actually care about Kotlin. I don't know why. But you actually want to provide them with a schema that's relevant to them. So because we've actually described this data using kind of this structural format, we can actually serialize this in a XSD or a JSON schema. And Baleen actually provides the ability to do that. So we can write a main function here and do print screen system out use and we can then, Baleen provides various extension methods that allow you to take a data description and encode it into that format. So what this is doing is it's taking that product description we ran, we'll go ahead and run it, and it should produce, it produces an XSD that describes, can you get out of the way? That's a problem with 5.1 coming out, or 5.0 coming out right before this talk. But you can see in there it's generated the XSD from that product description, so you could actually provide that to somebody else. Okay. Okay, so just to recap, Baleen is it provides all these features of best practices, the full data validation, adapts to what you cannot change, makes the messages relevant to the data source, and of course it is written in Kotlin. And it's open source, so anybody can use it. We also have a Slack channel if you have questions. We're always looking for feedback about ideas, etc. We've actually gotten feedback from the Kotlin user group on the original Baleen DSL, and we're much appreciated, and that came back into the system. But we're also working on some fun other projects like, okay, Baleen's great at dealing with legacy data. What if you're writing a new interface where you have a data class? Well, we can now generate, as of like last week, we can take a data class and actually generate a Baleen's data description with at compile time. We're also talking about like auto discovery of schemas and things like doing transforms on those data descriptions. So if you have several different data formats coming in that are rather the same but slightly different, you can actually transform them because you're working on the descriptions itself the same way you might work on code. And just want to say thank you to the Shopper team, who this is through their own hard-earned knowledge about how to do data validation that we came up with Baleen. Thank you.